Hello dear students, welcome back. This is Dr. Jyoti Shegokar and you are welcome in my channel Chemistry in Engineering. Guys, today's topic of discussion is fluid bed catalytic cracking, which comes under the heading of cracking, which is ultimately under the heading of fuels. So when fuels are studied, they are studied in terms of its properties, its all preparations, means how they are extracted, how they are fractionated, and what type of processes are done on the fuel to get the good quality or superior quality fuel. So one of the process is called as a cracking. As we know that in the process of cracking, the higher molecular weight hydrocarbons, which are fuels, they are converted into the lower molecular weight hydrocarbon by this particular process. So for this process, temperature, pressure as well as catalyst is applied. So according to that, there are number of types. So one of the type is catalytic cracking. Now the catalyst like the clay mix, zirconium oxide, bauxite, then different type of silica, different type of aluminum silicate, alumina particularly are used as a catalyst. So we will directly move towards our topic. So before that, guys, if you have not subscribed this channel, subscribe it, like the video and share it to your friends. Okay, so fluid bed catalytic cracking. So as this word indicates that there must be the presence of fluid. Fluid means nothing but liquid. But one thing I just want to say you that there is no any fluid or any liquid which is used there as a catalyst. Now why this is called as a fluid bed catalytic cracking? Because in this the catalyst which is used, like that I just said the examples like aluminum silicate, silica, the bauxite, clay mixed zirconium oxide, that fluids catalysts are there, but they are very finely ground, and as they are finely ground like a talcum powder, so they will behave like a just fluid, or in the some way it is behaving like a liquid. So this fluid bed catalytic cracking is also called as a moving bed catalytic cracking. There is another thing that due to which it is called as a moving bed catalytic cracking. So these both are one and the same, that fluid bed and moving bed catalytic cracking. Guys, as you know, cracking is done to get the good quality petrol particularly. So here there may be petrol, diesel or any petrochemicals which are cracked. By cracking process, the higher quality, superior quality fuel is produced. So this is having a very high significance in the industrial field to get the good quality fuel. Okay, now this is the construction, or we can say diagrammatic representation of the fluid bed catalytic cracking, which is must to study, which is must to write in your paper also, to draw this diagram. So here you can see different compartments are given. Very first is a preheater. Preheater as like the fixed bed catalytic cracking before heating. That is a preheater. So here preheater is having its temperature nearly 400 to 500 degrees Celsius, so that the fuel or the crude oil, heavy oil charge which is provided, it must be converted into some vapor state to get cracked, or for the proper convenience of the process. So here crude oil, that is heavy oil, has been provided from this particular preheater. So it is just, you can see here, it will move towards directly the next there are two different similar compartments or containers, so it is directly moving towards the next container, which is called as a reactor. So guys, firstly we will see how its construction is there. So reactor is there, which is just behind placed to the regenerator. Okay, now after regenerator, here one heading is given, it is called as a centrifugal separator, or it is also called as a cyclone separator. Now the centrifugal separator, just a single pipe is shown and it is moving towards the next fractionating column. So for the purpose of fractionation, fractionating column is there. Here there is a heavy oil charge. This particular heading is given for removing the uncondensed, or we can say that uncracked oil. Okay, now it is moving towards again next compartment, which is called as a cooler, where there is a cool air is passed from one side and removed from another side, and lastly it is moving towards the particular stabilizer where it stabilizes and all the gases will be removed. So this is about the construction. What is actually given in the diagram, that is construction. Then next is the working. After the construction, working is there. In working particularly, we have to study that how process occurs and what is the significance of each and every step. Okay, so first is a preheater, where in the preheater the temperature as it is given 400 to 500, it must be considered that the all heavy oil charge is converted into its vapor state. So this heavy oil charge, and in this there these two compartments. First, this first one is a regenerator, catalytic regenerator, and this is the reactor. So the firstly there is a proper working of reactor. So at first this particular from this preheater, the heavy oil charge is passed towards the reactor. So in this reactor the temperature and pressure is given. So here temperature is up to 500 to 600 degrees Celsius. Up to this temperature is there, and 3 to 5 kg per square centimeter such type of pressure is there. So in this reactor such a high temperature and pressure is provided. Okay, now here when once this particular preheater, here it is directly through this preheater, the fuel or the heavy oil charge is directly passed towards the reactor. Now in this reactor, as such a high temperature and pressure is provided with a catalyst. So this blue colored shown, it is nothing but the catalyst. So catalyst is, as you know, that it is nothing but the aluminum silicate or alumina or silica or zirconium oxide, which is with a mixed with a clay. So these all catalysts are there. They are very finely ground so that they will behave like a liquid. So as it is a fluid bed catalytic cracking. Okay, now here there occurs the process of cracking where high temperature, pressure as well as this catalyst is provided. So here only the conversion of 30 to 40% of crude oil or the heavy oil charge is converted into cracked gasoline. Totally cracked or purified gasoline, only 30 to 40% is produced here. While remaining is there remains the 3 to 4% of carbon residue will be produced, which is getting fixed into this catalyst. So oil, some heavy oil or some of the that is carbon residue will be just lock up into this particular catalyst. Okay, so after occurring this process, this all the mixture which is now converted into product because of feeding such a to such a high temperature and pressure and catalyst at the same time, all the cracking process occurs in the reactor, particularly in this particular container. Now after that the formation of a product is there, but still that product is in the mixture. So as this mixture of product is passed just ahead, so in between this particular fractionating column where differentiated or fractionated type of products will be stored and produced. So here in between this centrifugal separator such type of heading is given. So this is nothing but the particular cyclone will be provided, and when this oil, this heavy oil charge which is in the form of now vapors, and now it is cracked, means if in the heavy oil charge there is a mixture of decane, so that total decane, so that decane is now converted into methane, ethane, propane, butane, pentane. So they may be in the very random fashion they are present, and they are produced, but they are as in the mixture they are present. So they are to be differentiated. For that this centrifugal separator or cyclone separator has been provided. So when once it is fed to the cyclone separator, there occurs the process of separating by providing cyclone. So here separation occurs according to its molecular weight. So heavy oil charge will come first into the fractionating column and it gets settled at the bottom. According to that, some higher means higher molecular weight products which are produced comparatively, they will be there after the heavy oil charge. Then for example, formation of a heptane is there. So heptane will come first. After heptane there will be there will be hexane. Then after hexane there will be pentane, then there will be butane, then there will be propane like this. So like this will be arranged into this fractionating column, and when once it is reached to fractionating column, they are totally get fractionated and differently it can be removed. So next container is a cooler. So from this fractionating column, it is passed to the coolers, where the separately produced cracked gasoline has been cooled. So from passing the air from one side and removing from another side, here there is a that particular process has been done. So here you can see this particular pipeline through which the gasoline is proceeding. So at the same time, if there are found some uncondensed gases in the gasoline, uncondensed gases means they are not condensed, though they are present in the mixture, so they will be removed from this particular opening. Then those gasoline which is without uncondensed gases, but some condensed gases may be there, means those gases which are in the form of now liquid, so that gases are removed from this stabilizer. So when it's at once it is reached to the stabilizer, only the pure gasoline will be reached there and it will be stored. While these gases, here one of the heading it is given that those all the flue gases or any type of gases, they are removed from this particular gasoline, from this particular stabilizer. And here from the lower side, cracked, purified totally, that type of gasoline will be produced. Okay, now in this way the total process will occur, but after some time this those all catalyst which is provided, it will be totally get exhausted. That means it will get means it will stop its functioning. That is a cracking process, so it is to be replaced. That is one of the way. But according to some another if there are some another ways to replace it or to carry out its regeneration, the next container of regenerator has been provided. So here this regenerator is there, where there is a highest temperature just above 600 degrees Celsius, and a fresh air is provided to it. So one of the heading is fresh air. Fresh air, it is for what? At a very high temperature, fresh air has been provided for removing all the impurities, those all carbon black or all the type of carbon residue or some sticky product which is there should be removed. So for that, this fresh air is passed at a very high temperature. So above 600 degrees Celsius temperature will be provided to this regenerator. So and this one opening you can see here it is written flue gases. So gases which are there from the carbon will be produced, like carbon dioxide. If some hydrogen is there, hydrogen, that is a water will be produced. So in this way, that is for moving that flue gases, just escaping it into the environment, that opening is given. So in this way the this catalyst has been totally freshed. Now this fresh catalyst, here you can see one standpipe. So through this pipe the catalyst is passed towards the particular this reactor again, and the process will be continued. So at the same time this particular reactor is working, and at the same time this regenerator is working. Here you can see guys, some pipelines are there which are moving from one to another side. So don't get confused with this, don't get afraid with this. These are very simple. This is having a very simple type of working. Here when once this catalyst has been exhausted, it is passed towards this with the particular way, it is passed towards this regenerator for the regenerating purpose. And when once it is reached to regenerator, it is interacted with a very air with a very high temperature and very fresh air. So here there occurs the process of removing of all the gases, and fresh, once again fresh gas, fresh catalyst is attached with this particular pipeline which is there for the heavy oil charge. So with this heavy oil charge, this fresh catalyst will be moving towards the reactor. So at the same time, to this reactor, catalyst as well as heavy oil charge will be provided. So when it is passing through this pipeline, some of the type of temperature or that catalyst reacted with the oil. Okay, so here it is, if it is not possible sometimes to pass this actually with a gravity, when the that catalyst or the volume of catalyst increases, it will move towards the regenerator. But if it is not possible, sometimes there is a need of blower from this side. So blower may be used for the purpose of just pushing that catalyst towards the regenerator. So in this way, all the process is done. When once this catalyst getting fresh, it will move towards the reactor, and continuous process is occurred. Now here this catalyst is moving. If you notice that it is moving continuously towards the regenerator, and after this regenerator it is moving continuously towards the reactor. So that's why it is also called as a moving bed catalytic cracking. It is not just fixed, but it is moving. So that's why it is having another name of moving bed catalytic cracking. In this case, the time is time can be saved. At the same time, it will be more affordable. So as there is a use of regenerator, so by passing the fresh air, this catalyst can be continuously regenerated and can be used number of times. So in this way, this very simple, somewhat lengthy but very simple process is studied here, which is called as a fluid bed catalytic cracking. It is used, guys, for the cracking of particularly gasoline, diesel or some petroleum products. Okay. So with this, as you are staying tuned with me, it is my pleasure to say you thank you. And if you have not liked this video, like it, share it to your friends, and also subscribe if not already, and also hit the bell button as so as to get such type of videos. Thank you, guys. Thank you once again.